Okay, so let's revisit that problem that we were working on in class with the boat problem and the high tide problem. We're looking at part C where we said that the boat basically needs to dock when the water level is above 3 feet. And we said at 3, we can be drawing a horizontal line here and saying basically, well, when the water is high enough, these are the sections that we want our boat to dock. That way it can actually safely dock. So we have our equation already. We found that in part A. And what we need to do is say that if the water level is 3, we set that equal to 3, and we make it equal to everything else. 1.6 cosine pi over 6.2 times t minus 4.25 plus 3.6. And at this step, it's really just solving an algebraic equation, and you want to solve for your cosine value, your trig ratio. So we subtract 3.6, we get negative 0.6 equals 1.6 cosine pi over 6.2 times t minus 4.25. And then we divide both sides by 1.6, so that cosine is by itself. And negative 0.6 divided by 1.6, that gave us negative 0.375. And we said that in class, once we get this step, you can really just treat all of the stuff inside cosine. Really, this is just a lot of math involved, but really you can simplify it to cosine of x. So at this step, we should be thinking, when is cosine equal to negative 0.375? And you would be drawing the unit circle here and saying, I know that cosine is a negative value when we are in quadrant 2 and quadrant 3. So when we arc cosine both sides, we end up getting that the arc cosine of negative 0.375 is 1.95 equals, on the right side, all we're left with is pi over 6.2 times t minus 4.25. So this radian measure is 1.95 right here. Okay, so what we need to do now is actually calculate what that t value is at. So we can multiply both sides by 6.2 over pi, and in doing so this will cancel out. And then we add 4.25 on both sides. Just do that in your calculator, and you end up getting that t is about 8.1. And since we have 0.1, that's in terms of 0.1 of an hour, so that's 8 and 10 out of 60. So we're saying that this is occurring at basically at 8:06. And since this is 8, this is 8 a.m. Okay, so this is, since the question was asking us for when it can safely dock after noon, 8:06 is before noon, so this is not an answer we want. So what do we have to do? Well, if on the graph 8:06 indicates when this time occurs, we actually want to find its coterminal angle, when it's going to happen again, which is going to be over here. So because of that, we need to add on another cycle. So to do that, we take our 1.95, which is our 8:06 a.m., and we have to add on another 2 pi to that. So we take our 1.95 that we know the ratio is, and we have to add on 2 pi. And then we set that equal to pi over 6.2 times t minus 4.25. And then we can solve again for our value of t. In doing so, we just use our calculator. We end up getting that t is equal to 20.5. The other way that someone had mentioned in class was that if we know that the time was 8.1, we know that one complete period, we said from before, the period was, what was it, 12.4, I believe. The period was 12.4. The distance from here to here was a period of 12.4. So if we know that it happens at 8.1, we can just say 8.1 plus 12.4 also gives us our time. And 8.1 plus 12.4 gives us 20.5. So we end up getting the same answer. So you can solve it this way, or you can say 8.1, your previous answer, plus a period of 12.4 also gives you 20.5. So either way you get that answer. And 20.5, that's not an acceptable way to actually measure time. 20.5, it's kind of treated like military time. So to find the actual time, we know that after 12 hours, or rather this way, after 12 hours, then 13 o'clock is like 1 p.m. 14 o'clock is like 2 p.m. So 20 o'clock is going to be 8 p.m. So 20.5, that's half an hour, so that's going to be 8:30 p.m. Okay, so this is when we can actually safely dock, and this is afternoon, so this is the time that we want, not the 8:06 a.m. Okay, now the other scenario was we're only given that this was in quadrant 2. We also need to take into account the answers that occur in quadrant 3. So now we got to solve for that. So in this quadrant, in quadrant 3, we know that if this in quadrant 2 is positive 1.95, then going in reverse must be negative 1.95. So to find the actual positive angle of that, we need to do 2 pi, an entire circle, minus 1.95. And that answer will equal what we've been writing before, which was what? Pi over 6.2 times t minus 4.25. And this is again just calculator work. Just enter this into your calculator. Multiply by 6.2, divide by pi, add 4.25, and t ends up becoming 12.796 or 12.8. And if you just convert that into actual time, that's about 12:48 p.m. And you can just do the math on your own there to find it's about 12:48 p.m. Okay, so 12:48 p.m., that is afternoon. So because of that, this is definitely a time that we want to keep. Okay, now just for safe measure, you want to double check to make sure that its coterminal angle actually does or does not exist. So if we take into consideration how we solved the last problem, you know that one complete period was 12.4 hours. So if we just add 12.4 hours to 12.796, then we know for sure, well, 12 and 12 definitely give us 24, so we're going over 24 hours. So because of that, by doing the coterminal angle, that's going to bring us back into the next day. So we don't want to find its coterminal angle. All we have is this answer here at 12:48, and then our other answer was 8:30. And that's it for this problem.